Good morning, everyone. Today we are going to be taking chemistry, and the topic under the subject is Gay-Lussac law of combining volumes. Gay-Lussac law of combining volumes states that when gases react, they do so in volume. They do so in volume which has a simple whole number ratio provided the temperature and pressure is constant. N tán sọ fún wa ńbẹ̀ ni pé tí gases bá ti ń react, in as much tá keep pressure àti temperature constant, the gas will react in simple whole number ratio in terms of volume. Now nǹkan tán sọ ńbẹ̀ ni pé for example báyìí tí two volumes of hydrogen, say for example the reaction between the hydrogen and the oxygen is equal to water. Tí two volumes of hydrogen àti one volume of oxygen tó bá react, ó máa fún wa ní two volumes of water. Ṣé ti get báyẹn? Now nǹkan tó wá wà ńbẹ̀ ni pé the whole number ratio will now be 2 to 1 to 2. So the whole number ratio will be 2 to 1 to 2. Now eléyìí ni justification nǹkan tí Avogadro náà sọ tó sọ wípé equal volume of all the gases at the same temperature and pressure contain the same number of molecules. Gbogbo kinní wọ̀nyẹn náà láti kọ́ dáadáa nígbà yẹn. Nǹkan tí Avogadro sọ láti buttress point tí Gay-Lussac sọ ni pé níwọ̀n ìgbà tí wọ́n ní at the same temperature and pressure, níwọ̀n ìgbà tí pressure àti temperature bá constant náà, tí volume dẹ̀ wà in simple number ratio bí eléyìí tó wà two volumes, one volume and two volumes like this, ó mean wípé the number of molecules too will also be the same. So therefore this one will also be two molecules, one molecule, and this one too will also be two molecules. Níwọ̀n ìgbà tó bá jẹ́ pé two volumes, one volume, two volumes náà ni, then ó mean pé tó bá dẹ̀ ti jẹ́ pé wọ́n keep temperature àti pressure constant, ó mean pé wọ́n máa jẹ́ two molecules or two moles, one molecule and two molecules. So volume yẹn àti moles yẹn náà wọ́n wà interrelated. Ṣé ti get báyẹn? So that's just that about Gay-Lussac law. Now àwọn nǹkan kan dẹ̀ wà tó jẹ́ pé a tún gbọ́dọ̀ mọ̀ náà, mo kọ́ wa náà ní stoichiometry. 1 mole of any gas will always occupy 22.4 dm³. Ṣé ti get báyẹn? Mo dẹ̀ sọ stoichiometry báyẹn náà, mo ní 1 mole of 1 mole of any substance is equal to the molar mass of that kinní náà. Occupy iye mass tí 1 mole occupy, iye mass tí 1 mole any substance occupy, òun náà pè ní molar mass. Ṣé ti get báyẹn? Now ẹ jẹ́ ká wo àwọn example tó wà níbí báyìí, ká wo bá ṣe máa solve ẹ̀. Ṣé ti get? Now yeah. Now they say the combustion of propane in oxygen at STP, that is standard temperature and pressure, is given below. They say we should balance the equation. The first thing we do here, we have to balance the equation 1A C3H8 plus O2 H2O CO2. Báwo la fẹ́ ṣe báyìí? Now níta máa ṣe ó simple gan. This is carbon mẹ́fà lélẹ̀, carbon mẹ́ta lélẹ̀, ó máa nídìí mẹ́fà fún CO2. So ó ti di carbon mẹ́fà báyẹn. Now carbon ó máa nídìí oxygen mẹ́fà fún CO2. Carbon mẹ́jọ lélẹ̀, hydrogen mẹ́jọ lélẹ̀, ó máa nídìí hydrogen mẹ́rin, ó máa nídìí oxygen mẹ́rin láti produce H2O. Ó mean pé we need 10 oxygen. So a máa kàn sọ pé a máa fi 5 sí báyìí. Tá a bá ti fi 5 sí bí báyìí, nínú 10 ẹ mọ̀ pé mo sọ fún yín pé a máa nídìí oxygen bíi mẹ́rin, so máa jẹ́ 4 H2O bí báyìí. Now eléyìí náà máa jẹ́ how many carbon now? 3 CO2. So bó ṣe máa lọ́n tiẹ̀ ní àti balance ẹ̀ àti ṣe the first question báyẹn. The second one, wọ́n ní calculate the volume of oxygen needed. Nígbà tá a ti balance equation, ó mì pé pẹ̀lú nǹkan tá a pè tá a dẹ̀ ti sọ pé volume relate mọ́ molecules. Now ẹ jẹ́ ká wo bá a ṣe máa ṣe. So this one will be one volume, one volume, 5 volumes, 4 volumes, and this one will be 3 volumes. So bóun ṣe máa lọ tiẹ̀ nìyẹn. Now wọ́n ní calculate the volume of oxygen at STP needed to burn 50 cm³ of propane. So tí propane bí ratio wọn ṣe lọ ní ratio 1:5:4:3. Now tí propane bá jẹ́ 50 cm³, then automatically tá a bá fẹ́ wo ti oxygen tá a need, since tó yẹ pé one volume is corresponding to 50 cm³ bí báyìí, then ó mean pé 5 volumes of oxygen la máa need nìyẹn. So we now say that one volume of propane will produce 5 volume of oxygen. Now 50 cm³ of propane will now produce x cm³ of oxygen. In terms of proportion, a kàn máa sọ pé 1/50 is equal to 5/x. So by the time we do that, we have x will be equal to what? 50 times 5, yes. And that's what? 250 cm³ of oxygen la máa produce. Ṣé ti get it báyìí? So this one will be 360 cm³. Now ẹ ká wo number of moles tí H2O máa form. Number of moles H2O if there is 50 cm³. Now 50 cm³. Ṣé ẹ mọ̀ pé a sọ kinní kan lẹ́ẹ̀kan, mo ní 1 mole of any gas will occupy 22.4 dm³. Ṣé ti get it báyìí? 1 mole of any gas, 1 mole of any gas will occupy 22.4 dm³. And 22.4 dm³, torí volume tó fún wa ní báyìí is expressed in cm³, and we all know that 1000 cm³ is equal to 1 dm³. So therefore, if it is 1 dm³ is equal to 1000 cm³. Sorry, 1 dm³ is equal to 1000 cm³. So that one will be now if this one will be 22.4 dm³, then that means if I want to convert this one will now be equal to what? 22.4 dm³ will now be equal to 22.4 times 1000, and that will be what? 22,400 cm³. Mo ti convert ẹ̀ báyìí. Nígbà tá a ti convert ẹ̀ sìn, mo ti mọ iye, wọ́n ní 50 cm³ ló wà fún propane. So if that propane occupies 50 cm³, then the moles now, the number of moles of propane will be what? 50 cm³ over 22,400. How do I divide this? I don't have a calculator beside me. Let me get it. Let me get my calculator. Now 50 divided by 22,400. .0022 moles. So that's the number of moles it occupies. Nígbà tí 1 mole bá occupy 20.4, ó mean pé 50 mole bí 20.4 cm³. Ó mean 50 cm³ we have 0.022 moles. Now ẹ ká wo nǹkan tó béèrè lọ́wọ́ wa, torí eléyìí ló wà fún propane tá à ń sọ̀rọ̀ nípa ẹ̀. Now ẹ ká wo how many moles of H2O will be formed. ṣé mọ̀ pé a ti sọ lẹ́ẹ̀kan pé ratio wọn will always be equal in terms of moles and in terms of volume. So ilé máa jẹ́ C3H8 plus O2 ó dàgbà àti balance ẹ̀ lẹ́ẹ̀kan 5 lélẹ̀ to give 4H2O plus 3CO2. So tí 0.022 bá jẹ́ fún ilé 0.022 la ní fún propane, then ó mean pé 0.022 1 mole of propane, because 1 mole ló wà bí by 1 mole of propane will give us 4 moles of H2O. Now 0.0022 I think that's the answer. Yes, 0.0022 moles will give us X mole now of H2O. And how do you do that? 1 over 0.0022 equals to 4 over X, and that would what? X will be equals to 4 times 0.0022, and that's 0.0088. So that's moles of H2O. I guess that one is clear enough. Let's do the second example. They say calculate the hydrogen reacted with 6 dm cube of hydrogen is reacted with oxygen in a closed chamber. Now this is the equation of the reaction. 2H2 plus O2 to give 2H2O. Wọ́n wá ní 6 dm cube reacted with this 6 dm cube reacted with 2.4 dm cube of oxygen. Now tẹ́ bá wò dáadáa ẹ rí i pé ratio wọn ò equal dáadáa. This is 6, this is 2.4. Now tó bá yẹ pé 6 la fẹ́ lò ní norm, 6 dẹ̀ pẹ̀lú whole number ratio tán wí, tó bá yẹ pé 6 ló máa jẹ́ specific point wa tó máa jẹ́ reference wa tó jẹ́ pé òun la fẹ́ lò ní normal ground. Ó mean pé this 6 dm cube of hydrogen will require 3 dm cube on a good day. But the truth is that 2.4 dm cube náà fún wa. Ó mean wípé a lè lò tó 6 dm cube of hydrogen. Ó mean pé àwọn oxygen la máa lò as our reference point báyẹn. Ó mean pé hydrogen tó wà níbẹ̀ yẹn ó wà in excess, because oxygen ò tó, gbogbo ẹ̀dẹ̀ náà sọ pé ó react. Ó mean wípé torí tó bá yẹ pa fẹ́ lo gba hydrogen tán, ó mean pé ó máa require 3 dm cube of oxygen, but kò tó based on the molar ratio, kò tó nǹkan kan torí this ratio is 2:1 now, kò tó nǹkan kan. So ó mean pé oxygen ò tó, but ìgbà jẹ́ pọ́n sọ pé ó react, ó mean pé ilé la máa lò as our reference point. So tẹ́lẹ̀ bá jẹ́ reference point wa tí 2.4 dm cube bá wà ń bẹ̀, tá a bá máa lo gbọ́ oxygen tán, ó máa require tó kù, ó máa need the 4.8 dm cube of hydrogen. Ṣé ti get báyẹn? Ó mean pé hydrogen yẹn ló wà in excess, oxygen yẹn tó nìyẹn. Ṣé ti get báyẹn? Oxygen tó, hydrogen ló wà in excess. So 4.8 dm cube of hydrogen will react to 2.4 dm cube of oxygen, and automatically we máa produce 4.8 dm cube of water vapor. Ṣé ti get báyẹn? Because all these are gases. They are gases and they are gases like that. So now kí ni wọ́n sọ? Wọ́n ní calculate the composition of the resulting mixture. Only the resulting mixture, that means we are going to have 4.8 dm cube of oxygen, of hydrogen, to produce 2.4 dm cube of oxygen, and plus react with 2.4 dm cube of oxygen to produce 4.8 dm cube of H2O. Now nígbà tó ti rí báyẹn, it means that there are some volume of hydrogen that will not be reacted, tó yẹ pé ó ti pọ̀ jù. Ṣé mo sọ pé hydrogen wà in excess? So the unreacted hydrogen will now be equals to 6 minus 4.8, and that's what 1.2 dm cube. So 1.2 dm cube ló kàn ṣòfò dànù nínú reaction yẹn. Ṣé ti get báyẹn? I hope you find this video so helpful. If yes, please like our video, comment where necessary. We welcome both positive and negative comments, and subscribe to our channel if you are still new to the channel. Thank you so much. God bless you.